What is biochar? How is it made? Why do people refer to it as black gold? And how exactly does it help clean up the atmosphere? That's right. Today we're diving into the sooty black world of biochar. And we're going to attempt to answer the questions that I know you've just been dying to ask. Welcome to Glad Tidings, everyone. I'm Ben Wynne, and this is our weekly update on the progress we're making towards cleaning up the atmosphere. First, let's have a quick check of our totalizer, the amount of carbon cleanup funded to date through your membership. And the totalizer sits at 53,000 kilograms. So a fantastic amount, nowhere near enough yet. We need more members, we need to keep this momentum going, but it is going in the right direction, which is fantastic to see. And we're coming towards the end of September, which means we're coming towards the end of season 3. And I hope, I have my fingers crossed and I'm touching some wood, that we're going to have a big jump in that when we sign one of our enterprise partners, hopefully this time next week. Okay, and a saving for you, a really good one, a really exciting one, and this is with Pod. Now you might know Pod as Pod Point, they went through a rebrand, but this is electric car chargers for your home. So if you have an EV and you're interested in Pod, if you're a Glad member, you can get £55 off, and that's £55 off their hardware or £55 off their subscription product. So a great saving for Glad members and a real double benefit. Not only do you get to save on the product, you're also helping the environment because, of course, with an EV, it's not emitting quite as much pollution into the atmosphere. Okay, let's dive straight into the world of biochar. Biochar is one of those methods that we use to clean up the mess we've made of our atmosphere. And today I thought I would give you my take on exactly what it is, how it's made, and why we're using it within the Glad Climate portfolio as one of our cleanup methods. Now, we all know from our primary school days that there's nothing quite like a good show and tell. And indeed, I have brought some biochar with me today from our friends at Restored, and they kindly crushed up some biochar, put it in a little coffee bag for us. So I thought I'd actually literally get my hands dirty and show you some biochar. So here goes. Now I'm going to zoom in on this so you can see, but this is biochar. It's a coal-like substance, or more like charcoal really, and indeed it's made in a similar way to charcoal. So it's dusty, it's sooty, it's black. It doesn't really have much of a smell, and if you crush it, you can sort of crumble it down into a fine dust, and you can see, hopefully, it gets you very dirty very quickly. So that's why I refer to it as the sooty black world of biochar. So that's what it looks like, that's what it sounds like. I'm sure you won't be able to hear that. Maybe if I put it close to the microphone, you can hear it. But what is it? How is it made? Let's explore that. Let me bob that back in there. And see if we can carry on. So, the way in which biochar is made is through a process called pyrolysis. Now that's a very fancy, sciencey word, but really it's just heating up stuff. And in the biochar world, that could be wood, it could be leaves, it could be twigs or crop waste. But the pyrolysis bit is heating it up without oxygen. And that's the crucial piece here. That's the key bit. So normally you take a lump of wood, think of just a normal log that you could put on a fire. And when you chuck that on your campfire, it burns. It burns through combustion. And what's happening there is it's releasing carbon dioxide and smoke into the atmosphere as the wood decomposes, as you burning the actual carbon of the wood. So what you end up with is just ash. Pyrolysis is a very different process. You place that same log into an oven, so it's sealed, and it's sealed so that no oxygen can get in, and then when you increase the temperature, the oxygen escapes, and that means it's an, let me get it right, it's an anoxic environment, and that simply means without oxygen. That's crucial, and when you heat up that oven, you heat it up to a very high temperature. To make biochar, you want to be around 500, 550 degrees. That's the kind of optimal temperature. It depends a little bit on which product you're using, which feedstock or which wood you're using to make the biochar, but let's assume it's 500 degrees. That's roughly twice as hot as you would normally put your oven at home for cooking a roast or things like that. So that's pretty hot, and what happens during that process is the heat rearranges the carbon atoms in the wood into a super tough, almost crystalline substance. And that means that when the process is finished, that biochar gets scattered over the ground. But because that chemical reaction has happened, instead of being easily broken down by microbes and washed away, the carbon becomes really stable and stays in the biochar for a long, long time. Think of it like a charcoal skeleton that doesn't rot. And that's why the carbon sits safely in soils for hundreds, even thousands of years, instead of returning to the atmosphere. And when you've cooked it and when it's cooled down, you take the biochar out, you crush it into what we saw in the sample there, and then you spread it over farmland. Now, if you hadn't gone through that pyrolysis process and you'd crushed your log using some method into fine sawdust and chippings, when you put it over the farmland, it would just decompose because the carbon is not very stable. But the pyrolysis process makes the carbon stable, and it means the carbon is locked in there for hundreds, if not thousands of years. So really, biochar is the process of storing the carbon. It's captured by the tree, converted through pyrolysis, and then stored in a stable format and spread over farmland. And the thing is, with biochar, it's not just the carbon capture. It also brings benefits to farmers. You see, farmers love biochar because of what it does to their soil. When you spread the biochar over the farmland, it makes the soil more spongy, more sponge-like, helping it hold water for longer. So really, really useful in areas where there are extended dry spells. And of course, because of the climate change we've already created, we're going to face longer dry spells, and therefore biochar is also really useful in that regard. And it also acts like a pantry for plants, storing nutrients that the plants can draw on over time instead of them washing away. And it creates these kind of homes for microbes, which are really, really helpful for keeping and making the soil more healthy. The other benefit is that biochar, it is an alkaline substance. So you've got to think of your GCSE chemistry and think of the pH scale, so from acidic through to alkaline. Now, biochar is alkaline, so if you have a very acidic soil and you want to balance it out, make it more pH neutral, if you apply alkaline biochar to your soil, then you can rebalance its acidity and get it to the right level of pH for the crops that you're growing. And without biochar, farmers do this anyway. They do it with non-organic materials. So biochar is a fantastic benefit for them. It helps the crops grow, it reduces or rebalances that pH, and it's the byproduct, it's the co-benefit of that carbon capture. And this is why they refer to biochar as black gold, because you almost get to double dip. If you're a biochar manufacturer, you're selling the carbon credits. And a carbon credit really is a certificate to prove that you've removed or locked away a ton of carbon dioxide. And the way that that works is you measure the amount of wood, you weigh the amount of wood that you put into the oven, You push it through that pyrolysis process, heating it to 500 degrees, and when it comes out, you can measure the amount of carbon that's been stored in there based on the weights. And as long as your process is measured, it's reported on, and it's verified by an independent third party, you can sell a certificate, a carbon credit, which means you get paid for the production of the ton of biochar. Then you get to sell that biochar, the black stuff, and the farmer gets to spread it on his farmland. The farmer really appreciates that because it's a lot cheaper than buying the inorganic stuff, and of course it's much better for the soils. So that's why they call it black gold. So let's pull back a little and remind ourselves why our atmosphere is in such a mess in the first place. And that's because we've been burning fossil fuels for a long time. And what that really means is we've been digging substance out of the ground, oil, gas, coal, and burning it in order to create energy. Now today, because we're talking about biochar, a solid black substance, let's just think about coal, another solid black substance. So naturally I hear you ask, well, what is coal? How's that created? And let's just think about that for a moment. So think about the Earth millions of years ago, and parts of the Earth covered in swampy forest. Now that swampy forest, imagine a tree. A tree has got to the end of its life, it dies and it falls over into that swampy, liquid, airless environment. And it doesn't start to decompose straight away because it's an airless environment. It's lacking oxygen, or in science terms, it's anoxic environment. Now layers and layers of dead plants. Imagine one tree falls, another tree falls on top of it, and we're imagining a long period of time. So you get lots and lots of trees and mud and rock, and that creates pressure. The first tree that fell gets pushed further and further into the ground. And as you'll remember from your GCSE science, when the pressure increases, so does the heat. And so the pressure is increasing the heat, and the heat meaning that the liquid and the gases escape, and what you're left with ends up being a solid. First you get a peat, like a spongy, half-decayed mush, and then over a longer period of time it turns into lignite. And you keep going for longer, and that turns into a hard black coal. And if you think about biochar, really the very similar thing is happening. You're using the pyrolysis process to heat up the wood in order for the liquid and the gases to escape, meaning you're left with a solid black substance. And wouldn't it be wonderful if we could capture the carbon dioxide that we've emitted from the atmosphere through photosynthesis in a tree, and then convert that back into coal so it's stored underground? The thing is just, we don't have millions of years. So biochar is a fantastic proxy for the natural process that created the coal in the first place. We're huge supporters of it, and we really want to see it get to scale. Well, there you go. There's your whistle-stop tour of biochar. Now, I had the pleasure of seeing biochar being made end to end. I went down to Cornwall in the summer and saw our partners at Restored's, their facility there. Indeed, I got the opportunity to light the pyrolysis machine and see that process go through end to end. And during that time, I had the opportunity to sit down with Tom, the founder of Restored, and do a real deep dive. And Tom was very, very open about where he's at, the opportunity for Restored, the bigger opportunity for biochar globally. It's a really, really interesting conversation, and we're framing it as one of Glad's Chats With, part of the Chats With series. And when we finish the edit, that will be live on this feed very soon. I recommend you check it out. Okay, I think that's all for this week. Thanks for tuning in, and we'll see you next time. Stay glad.